Cool. So hello, welcome everyone. My name's Ben. I'm going to be talking about React hooks and specifically UseEffect and some cool use cases that came up with some of our client work. So let's get into it. A little bit about myself. Like I said, my name's Ben. Hello. I'm a technical lead here at nvisia. I've been here roughly 2 years. I am working in logistics now at a client, doing full stack development. I've actually not done any React for several months now, so sorry. But yeah, I'm really passionate about it. I love it. I worked with it for a long time with a client, so excited to talk to you guys. And yeah, just a little bit more about me. I like cycling, gardening, camping, just being outside. So. Yeah, and that's a picture of me before I had my haircut. So I'm going to start with a little introduction about hooks. You know, they were introduced in React 16. We're in React 18 right now. Has anybody not used hooks? No? Everybody's used them before? Has anybody not used React? No? I figured it's React. So, okay, so there's kind of three basic hooks, you know, use state, use effect, and use context. How I like to think of it, states like nouns, like things. Effects are verbs or like actions. And context is a little weird. I come from a back-end perspective. To me, it's like a dependency injection container. That's how I tend to think about that. Use effect and hooks in general were introduced in React to kind of replace a lot of the class lifecycle methods and hook into the React framework, if you will, and certain events. And the use effect hook specifically replaces these events. Component did mount, component did update, and component will unmount. So going a little deeper into use effect, what is it, or what does it do? You register your effect or your action that you want to perform with the React framework, and it also subscribes to certain values that you want to use to trigger your effect or their dependencies. So it runs, your effect runs at certain times. That runs when the component mounts initially, and then also when any of your dependencies update and their values change. And the call sign for use effect is this. You have your effect function, and then you pass an array of dependencies to it. In general, you kind of want to, all your dependencies that you use in your effect function, you generally want to include it in your dependency array. By no means do you have to. There could be some specific use cases where you don't. But it's good practice, and often if you're using like a linter, it'll bark at you and complain if you're not doing that. I can't think of any specific scenario where you would omit something, but if anybody has an example, feel free to share. But yeah, going on. So their effects, like I said, they're kind of actions that you want your app to perform. They can kind of be broken down into two different categories. Effects that require cleanup and those that don't. By cleanup, what I mean is anything that you need to gracefully shut down, like I said, I'm a back-end guy, C#, so like the iDisposable interface is what I think of. Anytime you need to clean up something. So a good example is like WebSockets. You open a connection, you want to close it up when your component unmounts. That's actually like the example that the React docs show. So how does the cleanup function work? You actually register it within the effect itself. So for anybody who's familiar with TypeScript, the effect function that I showed earlier, this is its signature. Essentially, it's a function that returns a function that returns clean. And like I said, the effects run at certain times within React, and the cleanup also runs at certain times. Cleanup runs when any of your dependencies change, and also when the component unmounts. And so when your dependencies change, there's a certain sequence that happens. Like, let's say our component mounts, our effect gets run, some of our values get updated, the cleanup function for our first effect is going to run, do any cleanup we need, and then our effect runs in its second iteration with its updated values. And then if the component becomes unmounted or things get updated again, that keeps repeating. So pretty straightforward, maybe, and I have a demo to kind of explain this a little. So let me pull this up. So I have a little timer set up that basically increments itself every 1 second. So it's like a stopwatch, you know. So looking at the code first, you guys see this okay? I have a hook defined here with some state variables, you know, whether the timer is running, you know, a state variable to hold the count. I have some buttons in the app that I'll show you in a sec. To start the watch, to stop it, to reset it, you know, pretty standard functions. And then this is the use effect part that I was talking about here. So we can see, here's where I call use effect. This is my function that I'm passing into it, my effect that I want to run, and then my dependency raise after it. You know, so every time one of these gets updated, it will run my effect again. And then, you know, what it does is I'm setting an interval, I'm incrementing the count by 1 every 1 second, doing a little logging, so in case you wanted to pull up the console, you could see. And then this cleanup part is really important. If I were to do a naive implementation of this without the cleanup, for example, like this, if we wanted to see what this looks like, any ideas what would happen? Anybody?
Go again.
Yeah.
Too many re-renders?
That's a good idea. Kinda. Not really too many re-renders. But let's just do an experiment and see. So let me start my timer. Okay, 1, 3, 7, 15, 30, 53. Okay, something's obviously wrong here. Let me try to stop it. Okay, I can't stop it. Let me reset it. Okay, cool. Well, it's still broken. So what's going on here? Let's look at the code again and see if we can kind of figure that out. Yeah, so what's happening is every time one of these things, every time our interval, you know, runs, we're updating count. So that's running our effect again. And every time that runs, we're creating a new interval that's running in parallel. So instead of just having one interval that we're clearing and resetting for 1 second every time this runs, we're creating a new interval next to it. And that's why the stop function doesn't work, because I have all these intervals that I lost reference to that are kind of running in the background. And it's really hard to, I don't know how to clear it up. So if we use this cleanup function then and clear our interval every time that our effect reruns, let's see what that looks like.
I'll go here, fresh.
Start it. So we have 1, 2, 3. Hey, it works. Crazy. And I can stop it because there's only one interval. You know, I can reset it, I can start it, and do whatever I want. Any questions about that? Pull the code again. By the way, all this code is hosted on a GitLab project that isn't publicly available yet, or we'll make it after the talk, so you guys can, you know, have a look at it and play around if you want.
So in theory, because count is one of your dependencies, you're starting an interval and clearing the interval each time the interval completes.
Yes,
right?
correct. Yep, because the count gets updated, then my cleanup function runs, clears the previous interval, and then the next iteration, and it creates a new one.
Could almost in this instance just be a set timeout.
Yeah.
But then it wouldn't be a good demo.
Right, exactly. Not very practical, but a good kind of example to show, why this is in play. So, like I said, not necessarily practical, but there are kind of better real-world use cases. So here's a great example. Request cancellation. So we have a scenario, we send a request, and then for whatever reason, we fire off a request right afterwards. We want to be able to mark our first request as canceled, meaning we don't care about it, and then only process the result of the second request and kind of discard the first one. This is pretty common, I think. And it gets kind of complicated because we're sending these requests, they're kind of asynchronous. We send a request and wait for a response. They could take, time to resolve, and maybe my second request comes in before my result for my first request. So I need a way to specifically cancel one and not the other. So I have a little demo for this as well, which I can show you guys. It's not quite as cool, but it works. And actually, so here we have this use fetch hook that I created. Just going through it very quickly, we have some things that we care about, the data, potential error, loading, and then we use this thing called Abort Controller. And then I'm using this with fetch, but by no means is that the only thing you can use this with. Axios is a big popular library. It's a little nicer than fetch. They also support Abort Controller. But essentially what happens is we pass in the signal from the Abort Controller when we fire off our request. And then if this effect gets updated, we have down here the return function to abort this call. So kind of what this looks like, this works, is I can, have my little endpoint that I know, I'll fetch it, and then it's loading, and then, this count should match this. Let's say I fire off 3. Well, those previous ones were aborted. I don't care about the result, and the only result that I get back is the same count that it should be. I couldn't really find a better way to kind of demo this. So, like I said, the code is going to be available for everybody to use. This is work that we did at a client recently to convert, an API, several API clients that we had to use hooks to be able to manage them better and be able to cancel requests. We had a scenario with a race condition where we were firing off 2 requests, and we needed to be able to cancel the first one. We would sometimes get the data back in not the same order, and it was affecting the application. Going back to presentation. Other use cases, we can clear timeouts. Another example we had at the client was toast notifications. So, we had a toast notification that appears on the screen for a couple minutes. Maybe you only want one notification at a time. You need to be able to clear out the other ones. Like I said, closing WebSocket connections is another great example. Clean up dominant listeners, whether that's like on hover or on click, whatever, any sort of events you can use and clean up with the cleanup function, and many more, I'm sure. And that's pretty much it. These are what I use for reference, and I'll open it up for questions now. Has anybody experienced this before? Would care to share an anecdote or other use case? Have people used this before at all? Did we already know about this? Was this like, not that interesting? No? Did anybody learn anything here?
The cancelable example is interesting because, too often you do get embrace conditions, and only tinkered with it enough to say, oh, this is acting weird. Let me go find a different solution.
Yes.
So
Yeah, it's definitely like a better real
Yeah.
world use case than
Or go look for someone else's custom hook that knows how to use UseEffect correctly. I'll just go steal that code. By the way.
Yep. Yep. Awesome. Anybody else? No? Cool. Well, thank you guys. And